think I know what this is.
Here, follow us.
No, everybody look away for like 2 seconds.
Oh, yeah. Here's a sneak peek of what we'll be making today. We'll set up a simple first-person player controller, create a coil head, create obstacles for the coil head to demonstrate how it can move around them, and that's pretty much it. If you don't know what a coil head is, it's a terrifying yet silent enemy in the popular game Lethal Company. Coil heads seem to show up at the most inconvenient times, and often their sudden appearance results in a frightening jump scare.
Oh, what the?
Oh.
Oh, God.
Here's what I gathered on how coil heads behave. Coil heads have let's call it a player detection radius. Once a coil head spawns, it'll roam around until it detects a player nearby. Then it'll chase the detected player, and if it touches you, you die. However, there is one way to stop a coil head. Look at him. As long as you stare directly at a coil head, it can't move. But if you look away, well...
There's a jester. There's a jester. Time to go. Time to go.
From a fresh Unity 3D project, let's create a 3D plane that will represent our ground. Now scale it up by 5 units, and there you go. We're almost finished. Next, we're going to create a very simple player object. So create a new empty game object, name it player, set the tag to player, create a new layer called player, and add that player to that layer. Next, drag your main camera as a child of your player. Set the FOV to 90, set the Y position to 1.75, and the Z position to 0. Let's head back over to our player object. We're going to add a new component called player controller. All the default values here are fine, except for the Y value in center. Set that to 1. Next, let's finally get to some code. Create a new script called player controller and attach it to your player object. The player controller script is very simple and it's out of the scope of this tutorial. So I'm going to fast forward through all of this. You can pause it here if you want to copy it, or you can use your own player script if you like. The only thing that really matters is that you have a main camera as a child of your player and that the tag and the layer are set to player. Let's go to the inspector and set our reference of our player camera field to the main camera. Now hit play.
I'm walking here.
Now that the player is all set up, let's start on the coil head. Create an empty game object and name it coil head. Add a rigid body to it and set is kinematic to true. Next, we're going to find a 3D model so that we can actually see our coil head. I'd like to use Mixamo because it's free and it's really easy to use, but you can pull a model from pretty much anywhere you want. I searched for the term bot and chose the first model that I saw. So download it as FBX for Unity, import it into Unity, and drag it as a child of your coil head game object. Name this new child model and set its scale to 2 to make it nice and tall. For some weird reason, the T-pose seemed really unnatural to me, so I just rotated the shoulders a little, and it looks a little better now. Now hit play and say hi to your coil head.
Hello there.
Time to make our coil head act a little more intelligent. So let's add some AI. So boot up Google and go to this link. This is an amazing and free asset that makes building enemy AI and simple pathfinding very easy. If you want to learn more about it, you can check out this Bracky's video. He goes a little more in depth about it, so check it out. But for now, just download the free version and drag it into Unity, importing all the assets. Create a new empty game object and name it Grid Manager. Then add a new component called pathfinding. This component will essentially scan the world space and relay all possible paths that the coil head can take to get to its destination. Add a grid graph and set the width and the depth to 60 and set the Y center to 0.1. Down in collision testing, bump the radius to 3. And for the obstacle layer mask, we're going to create a new layer called obstacle and assign it there. Now just disable height testing, and that's it for Grid Manager. Head on over to our Coilhead and add a new component called AI Path. Under AI Path, set the height to 2.5, the speed to 2, and the gravity Y value to -13. And for the raycast ground mask, we're going to create a new layer called ground and assign it there. And also for your ground game object, don't forget to assign the ground layer to it. Let's add another component to the Coilhead game object called AI Destination Setter. For now, you can set the target to the player transform just for testing. And hit play.
I'm gonna get you. I don't know how, but I'm gonna get you.
Now we're getting somewhere. But the Coilhead doesn't stop when you look at him like he's supposed to. So let's fix that. Create a new script, name it Coilhead, and attach it to the existing Coilhead game object we created before. Let's open up the script and we can delete the start and update functions. We'll start out by setting up the object's fields. Box collider is used when detecting if the Coilhead is seen by the player. Target layer is the layer of game objects that we want to detect. Speed is the movement speed of the Coilhead. AI path is used so that we can start and stop movement. AI destination setter is used so we can change the target that the Coilhead will chase. And current target is a reference to the current player that we're chasing. Let's create the awake function and set our component references for AI path and AI destination setter. Then set the AI path.max speed to be the field speed. And that's it for the awake function. Next, we need a way to fetch all players in a nearby radius. Create a private function called getPlayersWithinRadius. This function casts an overlap box on the target layer. Then it returns a converted list of all player controllers on the colliders that it hit. Now let's create our update function. First, invoke the function that we just made and set the return value to a new variable called possible targets. Now these three things are all that remains for the Coilhead algorithm, and then we're good to go. We have to check if any of the possible targets are looking at the Coilhead. Then if nobody's looking, we're going to choose a random player from that list and start chasing them. But if any of the players in the possible targets list are looking, we're going to stop our movement and remove the current target. Let's create another private function that returns a bool and accepts a camera as a parameter. We're going to name this function isGameObjectInView. And essentially all this function does is check if any part of the Coilhead is within the camera's view. It does this by calculating the boundaries of the camera's view, and it checks if the Coilhead's bounding box is within these boundaries. If this initial condition passes, it then checks if the Coilhead is actually visible and not hidden behind another object. This is done by getting the corners of the Coilhead's bounding box and casting rays from the camera to each of the corners. You'll notice that the function getCorners is not found. That's because we're about to add it as an extension to the bounds class. This is a simple method that looks complicated, but all it really does is just store the 8 points of a bounding box into a vector 3. From your code editor, create a new file called boundsextensions.cs and add this extension function. And I'll have all the code available for free in the description if you don't feel like copying from the video. After you add the method, go back to the Coilhead script and make sure that the compiler stopped complaining. Now add a private function called isAnyoneLookingAtMe. All this function does is iterate over the list of past player controllers, and then it calls the isGameObjectInView function on each camera that's attached to the player controller. It returns true if any players are looking and returns false if all players are not looking. Now invoke this function in our update method where we left our step 1 comment. Now we need a way to set the current target of the Coilhead to chase. So create another private function called setCurrentTarget, and as a parameter have a nullable game object called target. If the past target is not null, Then set the AI destination setter .target to it, and also set the AI path .can move to true. This basically initiates a chase. And if the target is null, set both those values to null and false. Finally, head up to the update method and add the conditional logic to switch the current target based on whether anyone is looking at the coil head. And there we go. That's all the code we need to recreate Coilhead from Lethal Company. So go back to Unity, click on your Coilhead object, set your box collider reference, set the speed to 5, and set the target layer to player, and hit play. Now when I look away, he starts chasing me, but when I stare him down, he stops dead in his tracks, just like in the game.
Think I'm gonna let somebody stare me down?
Let's make this a little more interesting. I quickly added these simple walls just to demonstrate how the coil head can navigate around these obstacles and still find a path to the player that it's chasing. You can create whatever type of obstacle you want, just make sure that there's a box collider attached to it and the layer is set to obstacle. Notice that when I walk behind a wall, the coil head starts chasing me again. In my opinion, this is a key mechanic of the coil head that creates tense situations that seem impossible to escape. And that's pretty much it. Feel free to expand on the code, adding different mechanics, switching out the model, or pretty much anything you can think of. Thanks for watching, guys. See ya.